We're going to go ahead and start looking at some trigonometry. So we're going to start off by looking at what angles are to begin with. Now, here we have an example of an angle. We would say ray, and angles are made up of two rays. OA is your initial side, and then your terminal side is OB, that ray. Your vertex is where the two rays come together, in this case O. An angle is in standard position when we have the vertex at the origin and the initial side on the positive x-axis. So if we take our initial side and we would rotate counterclockwise like this, we would say that's a positive angle. If we would take our initial side and rotate it clockwise like this, we would say then that would be a negative measure of an angle. We also have quadrantial angles. Quadrantial angles are those that end up on our quadrant axes. So this would be like a 0-degree angle. This would be 90, 180, 270, 360, and so on. Or if we went backwards, if we started at 0, went backwards, this would be negative 90, this would be negative 180, and so on. So just be aware that quadrantial angles refer to those that end up on your x and y axes. Now, coterminal angles are angles that have the same position but different measures. So consider this one here. It's a 30-degree angle, but instead of just going from here up to 30, if I started here, went all the way around to 360 and then went 30, then I would have an angle that would be 390. Or if I started here, went all the way around twice, which would be the 360 plus another 360, which would be 720, and then went my 30, that would then be a 750. Or if I started here and went backwards a full or almost a full revolution to here, that would be going backwards negative 330. So some coterminal angles to 30 degrees are these. Basically, you're adding or subtracting full revolutions, and you can do that more than once. Remember, acute angles are between 0 and 90. Obtuse angles are more than 90 but less than 180. Also remember, complementary angles are two angles that add up to 90 degrees, and supplementary are two angles that add up to 180 degrees. Now, just like when you're measuring length, there's different ways to measure it, like inches, feet, meters, kilometers, miles. There's different units. There's also different units to measure angles. You're used to measuring angles in degrees. A second way to measure angles is in radians. So we'll get to that on the next slide. But sometimes you'll come across this notation. That's 25 degrees, it's 43 minutes, and then 37 seconds. You guys are familiar with hours, minutes, and seconds. You know that there's 60 minutes in an hour, and there's 60 seconds in a minute, or 60 times 60 seconds in an hour. That same type of conversion works when you're dealing with degrees, minutes, seconds. When you're looking at number of minutes in a full degree, that's 60 minutes in a full degree. Or how many seconds make up a minute? It's 60 seconds that make up 1 minute, or 60 times 60 seconds that make up a full degree. So if you needed to convert this to just degrees without the minutes and seconds, you could type in your calculator 25 degrees. Then you could go and say, well, this is 43 out of the 60 seconds, so go 43 divided by 60. This is 37 seconds out of 60 minutes, and then you'd have to divide by a second 60, or 60 squared, to get it into degrees. You could type that in, and you would get this. A second way you could do it, if your calculator is in the degree mode, you could go 25. Now we got to get the degree symbol. The degree symbol on your calculator, you need to go ahead and go second apps, which is your angle menu, select your degree, then type in 45. Then you have to go back to second apps, get your minute symbol. Then you type 37, and now your quotation mark, which is used for your seconds, is alpha plus. So that's just above the enter in the lower right hand corner. If you type that in like that, you can also go ahead and get the exact same answer, but your calculator has to be in the degree mode. Now, you may be asked to go ahead and take something like this in degrees and change it back into degrees, minutes, seconds. So what I would do is I would type in 25.7825, get your degree symbol from second apps. Then after I get my degree symbol, I would go back to second apps again, then select number 4, which is your DMS, and it'll change it to degrees, minutes, seconds. So I would more than likely use your calculator, but if you wanted to do it by hand, you could, for the most part, do it like this. So 1 radian, as we mentioned before, angles can be measured in radians, is defined by the central angle of a circle subtended by an arc length of the radius of the circle. Now, you're probably not used to seeing the word subtended, and you may not know what that means, but that's okay. But just know if you ever see the word subtended, you're referring to your definition of a radian. Basically, in layman's terms, it says your angle in radians, we'll call it theta, is your arc length. That's this curved distance on your circle going from A to B for your angle, which we call S, divided by your radius. So it's arc length divided by your radius is your definition of an angle in radians. So let's consider how many radians are in one full revolution of a circle. We know a full revolution is just your circumference, 2 pi r. Well, we take our arc length, our full revolution, 2 pi r, divided by your radius. So you get 2 pi r divided by r. Well, the r's are going to drop, so one full revolution is just 2 pi. So if to go all the way around once is 2 pi, to go halfway around to 180, we know would just be pi. So pi radians is equal to 180 degrees. If you go, instead of going to 180, we go to 90, which is half of that. That means we would just be then half of pi, or pi over 2. Or if we're going to 270 degrees, which is really 180 plus 90, it would then be pi plus a half of pi, or 3 pi over 2. Now, 180 degrees and pi radians are exact same spot on your unit circle. So if we go pi over 180, that's a special form of 1, or 180 over pi, that's a special form of 1. We would use this right here if we're trying to convert degrees to radians, because here we have degrees in the bottom, and it would cancel out our degrees. If we were trying to convert radians back to degrees, we would use this one here because we're trying to end up with degrees and we have degrees on the top. So if you would see the angle of theta is equal to 5, because there's no degree symbol, it's assumed to be radians. If you meant 5 degrees, you'd have to have the degree symbol. So if you forget to put the degree symbol down when you really meant something in degrees, I'm going to interpret it as radians. So if there's no degree symbol, your angle is assumed to be in radians. So let's go ahead and convert these from radians to degrees, or vice versa. So here, we're starting out with degrees. We want to end up with radians. So we want to get rid of degrees. So that means we need to multiply by where 180 degrees is on the bottom. So now you have degrees in the bottom, cancel out degrees in the top. So you could write it as one big fraction. Once again, the degrees would cancel. I would go ahead, use your calculator, just type the 225 divided by 180 in your calculator and fractionize it. And just know that your answer will have a pi in it. Well, when you do that, you'll get 5 over 4, and you'll know you'll have a pi. Or, like this problem here, which radians, we need to get it back to degrees. So if we want to end up with degrees, we got to do that special form 1 where degrees is on the top. Now here you'll notice the pi's drop. So on my calculator, I would go 7 times 180 divided by 4 and write 315. Remember to put your degree symbol down. So on this one, we already have degrees. We want to end up with radians, so I want degrees in the bottom to cancel out. Notice you can cross out the degrees end of 0, degrees end of 0. Then you'd have 33 over 18. You could either simplify that by hand or use your calculator, and you get 11 pi over 6. When you're typing it into your calculator, do not include pi. Just know that there'll be a pi in your answer. Or here, we want to end up with degrees, so we want degrees in the top. Once again, your pi's drop. We get 180 over 3, which is 60 degrees. Now, if we have something like 3 and we want to convert it to degrees, minutes, seconds, first of all, we got to take our 3 radians. We know it's not degrees because there's no degree symbol, and convert our 3 radians to degrees. That means we need to multiply by that 180 degrees on top over our pi as our special form of 1. We multiply the top, put it over pi. So we end up with an exact answer of 540 degrees over pi. But to get that into degrees, minutes, seconds, I type this into my calculator, get the approximation, then go and DMS it, which once again is second apps, arrow down to number 4, and then we would get this. Couple other things here. If we take our definition of a radian, which we know is theta is equal to your arc length of S over R, if you try to get S by itself, you'd have to multiply both sides by R, and that's really your arc length right here. Over here, we can find the area. Now, your arc length, once again, is, so this arc length right here is this curved distance. Now, if we're looking at area of a sector, that's the area of this whole big piece of basically a pie shape. That whole big area, that formula is this. But for both of these formulas, you need to make sure that your angle is in radians. If your angle is not in radians, you will not get right answers. So to use these formulas, make sure your angles are in radians. You may be asked to find angular speed or linear speed. Angular speed is your central angle in radians divided by time. So just your angle in radians divided by your time. If you're looking for your linear speed, that's your arc length divided by time. So just be sure that you're aware of that in case you're asked to find those.